Now for our example 5, we have to sketch the graph of letter A, y is equals to 2 raised to x, and y is equals to 2 raised to negative x. And for B, we have y is equals to 2 raised to x, and y is equals to negative 2 raised to x. So we need to describe the graphs and its properties. So for the first part of the solution, we need to compute the function values and list the results in the table. So let's compute. So for letter A, so we already computed values, the range, the domain, with the domain, real numbers from negative 2 to positive 2 for y, or f of x equals to 2 raised to x. So the values are, for f of 2, f of negative 2, we have positive 1/4. For f of negative 1, we have positive 1/2. And for f of 0, we have positive 1. And f of 1, we have positive 2. And lastly, we have f of 2, which is equals to positive 4. For y is equals to f of x equals to 2 raised to negative x. Using the domain negative 2 to positive 2, we have f of negative 2 equals to 2 raised to negative. So negative 2 as your x, so we have 2 raised to negative 2. So negative 2, that is positive 2. So we have 2, we have equals to 2 raised to 2. So that is equals to 4. For f of negative 1, we have 2 is equals to negative 1, so negative 1. Double negation equals to positive, so we have 2 raised to 1, that is equals to positive 2. For f of 0, we have 2 raised to negative 0, so we don't have negative 0. It just means that this is 0. So 2 raised to 0 is equals to positive 1. And for f of 1, we have 2 raised to negative positive 1. So we have equals to 1 over 2 raised to 1. So this is the law of negative exponents. So 2 raised to 1, that is equals to 2. So this is equals to 1/2. And lastly, for f2, we have 2 raised to negative 2, that is equals to 1 over 2 raised to 2, or the 1/4. Writing it in a table, we have this set of tables. So we have 1/4, 1/2 for the range in the first function, y is equals to 2 raised to x. Then for 0, we have 1, then 1 to 2, and then 2 to 4. And here we have 2 raised to negative x. We have, for negative 2, we have 4, negative 1, we have 2, 0, 1, 1 positive 1/2, and 2 positive 1/4. Now, for letter B, so we have again y is equals to f of x equals to 2 raised to x. So we have values 1/4 for f of negative 2, value 1/2 for f of negative 1, and 1 for 0. So we have, for 1, we have 2. For f of 2, we have positive 4. So we've already computed it in the first part, example 1 and example 2. So that's why we run through it here. And next function, for letter B, we have f of x, or y, is equals to negative 2 raised to x. So substituting values from negative 2 to positive 2, we have f of negative 2 equals to negative 2 raised to negative 2. So we first simplify 2 raised to negative 2, that is 1 over 2 raised to 2. So negative of that. So 1 over 2 raised to 2, that is 1/4. That is, this is equivalent of 2 negative 1/4. For f of negative 1, we have negative 2 raised to negative 1. So we have negative 1 over 2 raised to 1. So this is equals to negative 1/2. For f of 0, we have a negative equals to negative 2 raised to 0. So 2 raised to 0 is equals to 1. So we have equals to negative 1. So we negate this to positive 1. Then f of 1, we have negative 2 raised to 1. So we have 2 we add on equals to negative 2. And lastly, we have f of 2, which is equals to negative 2 raised to 2, that is negative 4. So writing it in a table, we have this table of values. So negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2, and then 2, 4, 4, y is equals to 2 raised to x, or f of x equals to 2 raised to x. And for y is equals to negative 2 raised to x, we have a negative 2, negative 1/4, negative 1 comma, negative 1/2, 0, negative 1, 1, negative 2, and 2 raised to 2 and negative 4. So for the second part, we need to plot those points on a Cartesian plane and connect them with a smooth curve. So since we are graphing it, we need to plot those points in the plane. So for letter A, we have this table. So this is the graph. For y is equals to 2 raised to x is the red smooth curve, and y is equals to 2 raised to negative x is the black curve. So when we plot these values, this will be the curve. For letter B, this is the table of values. So we have this graph. So again, this is our y is equals to 2x. It's just the same with this one. We just compress the graph itself. And for the y is equals to negative 2 raised to x, this is the curve. This is the black curve for that function. If we are going to plot this ordered pairs, it will turn out to have this smooth curve. So what are the properties of these two graphs? So so we have the same here, y is equals to 2 raised to x. That's why we have 3 functions here. So these 3 functions have the same domain. So they all have a domain of set of all real numbers. So as we can see, it can be from negative to positive infinity. And the range differs. So these first two functions have a range of 0 to positive infinity, because as you can see, this function is in the form of f of x equals to b raised to x, So it's just that your x here is negative. And your y-intercept is equals to 1, so they are the same also. And for the third function, we have a range from negative infinity to 0 rather. So the values of your y is from negative infinity to 0. And its y-intercept is negative 1. So as you can see, this coincides with the y-axis at y is equals to negative 1. And lastly, the horizontal asymptote are all y is equals to 0. So they are all approaching y is equals to 0, but they all not touching it. For the remarks of these graphs, so we have for letter A, the graph of y is equals to 2 raised to negative x, or this black smooth curve, is a reflection of the graph of y is equals to 2 raised to x. So this red graph. So as you can see, they are just a reflection. This one is just a reflection of this about y-axis with this one. So a mirror image or a mirror curve. So this means that the graph of b raised to negative x is a reflection of the graph of b raised to x. Y is equals to b raised to x about y-axis. And for letter B, we have the graph of y is equals to negative 2 raised to x is a reflection of the graph of y is equals to 2 raised to x about x-axis. So it is shown here that when you flip this about y x-axis, it will be the black curve, or dy is equals to negative 2 raised to x. So meaning that the graph of negative y is equals to negative b raised to x is just a reflection of the graph of your y is equals to b raised to x about x-axis. So there is a missing x here, so there is an exponent x. So that's it for the example number 5.